messing with it down here.
Go.
This unit is on unit conversions. We will be learning how to use an equality to build a fraction with a value equal to 1, which we call a conversion factor, and then use it to convert a measurement in one unit to a different unit. Let's try some examples. Going back to grade school, when you first learned fractions, one of the things you learned how to do was to reduce them to lowest terms. So we had to look at what's common to 10 and 12, which would be look at things that multiply that would be common that we could reduce. So let's see. 10 would be 2 times 5. And there's a couple of different things we could use for 12, but let's use 6 times 2. Now, you'll notice that there is a 2 on top and bottom. We really should have a division line there. And because one's on top and one's on bottom, we can reduce that out, and we would simply have our answer to be 5/6. Again, we used something that was the same on top and bottom to make it disappear. Now, another example from grade school would be when you had fractions and you wanted to add them and you needed a common denominator. So let's say we had 3/4 and we needed the denominator to be a 12 so that I could add it to another fraction that had a 12. So we knew that we needed to feed something to the 4 to bring it up to a 12, and hopefully you recognize that that needs to be a 3. But this is like twins. If you feed one of them, you have to feed the other one, so we have to feed the top a 3 also. And so we would end up actually multiplying those and figuring out what we get. So the 4 times 3 gives 12, and the 3 times 3 gives 9. Notice in both examples, I've changed what the fraction looks like, but I haven't changed its value because I'm dealing with the 3/3 here, which has a value of 1, and I was dealing with the 2/2 in the other example, which deals with 1. So we're going to be looking for a fraction that has a value of 1 to change the value of what I'm starting with. Now, our first example of actually doing unit conversion is dealing with seconds and going to minutes. So what I need is an equality that we know for how many seconds are in 1 minute. And actually, let me start with this over just a little bit because I know I'm going to need more room. So, now, how many seconds are in 1 minute? And I'm picking that because I know the minutes are larger, so I'm going to let it be 1, and hopefully we know that there are 60 seconds in 1 minute. That tells me that I could use a conversion factor of 60 seconds over 1 minute, or I could use a conversion factor of 1 minute over 60 seconds. And until I start the problem, I don't really know which one I'm going to need. So let's see what we've got. I'm going to start with the number that I'm given. So I'm going to start with seconds. I'm going to draw my fraction line, and I'm going to draw it straight across. And this is where it gets a little weird, because for those of you that have never done dimensional analysis before, you're not going to see what I'm really doing until I'm done. This is going to be your fraction line. This will always be a division line. This is going to end up representing multiplication. But let's go back and see. I've got seconds here, and from the very first example, knowing that I want to get rid of seconds so that I can have minutes, I'm going to have to put seconds down here. Because if I put seconds down there, it's going to allow me to cancel them out. But that means then I need minutes on top. So that tells me which of these fractions I need. I need the one that has minutes on top and seconds on bottom. So now we've got the units working, and you've heard me say if you can make the units work, your numbers have to work. So now just fill in everything we were given. So the original problem said we had 350 seconds, and we know that 1 minute gives 60 seconds. This original measurement has 2 sig figs, so that tells me that I need 2 sig figs in my answer. We never use the conversion factor within our sig figs because this is a given. We're saying that 1 minute is exactly 60 seconds, so there's no error in that. So we don't need to deal with precision here, so it doesn't enter into the sig figs at all. Only the original measurement that you're given will enter into the sig figs. So now we need a calculator to do this, so let's pull up the calculator. And we have 350 divided by 60, and I need 2 sig figs. So to 2 sig figs, those 3's are going to drop off, and my answer will be 5.8. And my units are minutes. And that's all there is to it. Okay. A second example is dealing with the same units, but we're going to go backwards. So I need, again, the same conversion that I already had that dealt with the fact that 60 seconds equals 1 minute. And I've got the same conversion factors that 60 seconds over 1 minute would be equal to 1, or 1 minute over 60 seconds would be equal to 1. I don't know which I'm going to need. I'm going to let the problem tell me which I need. This time though, I'm starting with minutes. So I need to have minutes to start my problem with. And then I need my setup. And guys, you're going to need one of these on every problem. So you might as well go on and draw it. So now, what do I need down here that'll cancel out with the minutes? I need minutes again. That'll cancel out from top and bottom, and if I put seconds on top, that means I'll be left with seconds as my answer. And so that's how we're going to set it up. Notice again, minutes are gone, and it leaves me with seconds. If I go back and fill in my numbers, can't be wrong. So we have 5.2 minutes, that's what we started with, and we have to use this fraction now that 60 seconds is 1 minute, and whatever I get from my calculator, my units are going to be seconds, and then I'll be done. So let's pull out the calculator, and we have 5.2 times 60, and that equals 312. I only need 2 sig figs though, because that's what the initial measurement has. So I'm going to draw the line between the 1 and the 2. So it's 312. So when I draw the line between the 1 and the 2 is not going to round the 1 up, so this should be 310. Now, another example dealing with units of time, except it's not minutes and seconds, it's hours and seconds. So, let's see. What we know from the last examples were that 60 seconds is 1 minute. But that doesn't get us to hours. So then we've got to use the fact that we know 60 minutes is equal to 1 hour. So that means I can use 60 seconds over 1 minute, or 1 minute over 60 seconds. And then over here, the same thing, except 60 minutes to 1 hour, or 1 hour to 60 minutes. So now, let's set up our problem. This is what we're starting with. So that means we have to start with hours. So I'm going to need a line there to give me hours, but that means I need hours on bottom so that they will cancel out. So the only one of these that has hours on the bottom would be this one right here. So that means I'm going to need minutes on top, which is nice, but that doesn't give me the seconds. So I'm going to have to do a second step. So that means I need another line and I need more bar extended, because now I need minutes down here to make minutes go away, which is going to force me to use seconds on top so that I'm left with seconds. So notice, hours are gone, minutes are gone, and you're left with seconds. So if I go in and fill in all the numbers, we should be good. So we've got 3.2 hours. You always put down the number that you start with. Now, our fraction with minutes over hours, it's 60 over 1, and now both of these are gone. I can't use them again. And so then I look over to here, and I want the one that has seconds on top with minutes on bottom. So again, it's going to be 60 over 1. And when I'm done, because minutes are gone and hours are gone, I should be left with seconds. And because this has 2 digits, I'm going to need 2 significant figures in my answer. So let's pull up our calculator. We have 3.2 times 60 times 60. So we have 11,520. We're going to go to 2 sig figs. And remember, the 5, there are special rules for rounding with the 5. Anything after the 5 makes the 5 round up. So this is going to have to round to a 2. So my answer should be 12,000. Whoops.